So today's experiment is to determine the temperature coefficient of resistance by using platinum resistance thermometer PRT and Carey-Foster bridge. So the contents of the experiments are: aim of the experiments, number 2 introduction, number 3 apparatus required, number 4 theory, number 5 working principle, number 6 methodology, number 7 result and interpretation. So the aim of the experiment. The aim of the experiment is to determine the temperature coefficient of resistance using platinum resistance thermometer. So the introduction. The resistance of platinum wire changes almost linearly with temperature. Thus, we can find its temperature by measuring its resistance and use it as a thermometer. We can find the difference between resistance using Carey-Foster's bridge. That's why platinum resistance thermometer is specially constructed for this experiment. So the apparatus required are Carey-Foster bridge, which is an higher level of meter bridge. Number 2 galvanometer. Number 3 5-volt DC power supply. Number 4 2 fractional resistances. Number 6 a platinum resistance thermometer. Number 7 an electric heater. Number 8 connecting copper wires. Number 7 a jar of beaker for water bath. So the theory. Platinum resistance thermometer PRT. It consists of fine platinum wire, platinum coil, wound on non-inductively on mica frame. The end of the wire are soldered at points A and B, from which wire two thick leads run along length of the glass tube that enclose the setup and are connected to the two terminals PP fixed on the top of the cap. Also another set leads run parallel to this connected to the terminal CC fixed on the cap. These are called compensating leads and are joined together inside the glass tube. During operation, generally a fractional resistance is connected in series with CC. Carey-Foster bridge. The jagged part is a copper stripe with 4 gaps M and alpha, N plus beta, X and Y. These 4 act as 4 arms of Wheatstone bridge. 2 no resistances P and Q of 10 ohm each are at X and Y, and in gap M and N, PP and CC plus R are connected, thus forming a complete Wheatstone bridge. And thus by calculating difference between PP and CC plus R, we can calculate resistance of PP. So the working principle. Platinum resistance thermometer. PRT works on the principle that the electrical resistance of metal changes linearly with temperature. And Carey-Foster bridge works on the principle of Wheatstone bridge, that is the null point we got Joule current through the galvanometer. Now we go to methodology. We prepare the set of shown same as shown in next slide. For a particular temperature, room temperature of water bath, we made a Wheatstone bridge on Carey-Foster bridge with 4 arms PP plus 1, CC plus R plus 100 minus 1, P and Q, where PP is the resistance of platinum wire, CC plus R is the resistance of compensating wire, P is equals to Q is equals to 10 ohm, and L is the length of the null point. Here we find the null point with CC plus R on right side first, and again putting the same on left side for the particular temperature and fractional resistance. Again we repeat the procedure for another fractional resistance. Now we change the temperature, steam point at water bath, and again repeat the above procedure for this temperature also. Note the observation in the table and calculate the value of R1 and R2 with the help of the lengths obtained at null point, and then subsequently add temperature coefficient of resistance by using the formula alpha is equals to 1 by T R1 by R2 minus 1. So the experimental setup is given. Result. To calculate the value of R, we use the following formula. R is equals to R1 I2 dash minus I1 dash minus R2 bracket I2 minus I1 whole divided by I2 dash minus I1 minus I2 minus I1. To calculate the value of temperature coefficient of the resistance, we use the following formula. Alpha is equal to 1 by del T R1 by R2 minus 1. Alpha is equals to temperature coefficient of resistance. Del T is equals to temperature difference between two temperature points, that is equals to T1 minus T2. R1 is equals to resistance of platinum wire at temperature T1. R2 is equal to resistance of platinum wire at T2. Interpretation. During the experiment, we came across several doubts and questions such as why we use a fractional resistance in CC and why it is called compensating wires, as CC is just a copper wire with very negligible resistance, so to compensate the resistance of PP, we connect a fractional resistance small r. What happens if steam point or power supply is maintained for longer time? Temperature of the Carey-Foster bridge wires at PP and CC increase, thus the resistance. Why Carey-Foster is used here, not the meter bridge? It is used because we can calculate the differences between two resistance but can't be done with meter bridge.